Now let's talk about our last subject will be about transport maximum. So maximum rate at which a substance can be moved across the membrane. So we're talking about the proximal convoluted tubule and so remember the PCT and the nephron, that's the one that's trying to reclaim as much of the nutrients and the good stuff as possible. But it's limited by how many transporters there are and its length and how many, yeah, it can't reabsorb everything. It does have a maximum rate at which it can actually reclaim stuff. So let's do analogy time. Okay, let's bring this back to its original context. Why do I use this as a metaphor? All right, so the metaphor is, remember all that food was coming out of that one chute and shooting down that conveyor belt down to the other side? Well, the thing is that that hole where all the food was coming out, the sushi or that chocolate in the tip, and all the things in your blood filter out, or not all the things, but remember when your blood filters out through the renal corpuscle, then you also filter out things like ions, water, even things like nutrients such as glucose, amino acids, and vitamins as well. So the thing is that all this gets pushed into the filtrate. And what's the first part of the renal tubule that is after the renal corpuscle? What's the part that's closest? The proximal convoluted tubule. So that conveyor belt is that first part that as soon as those nutrients are coming out. Same with the renal corpuscle and the proximal convoluted tubule. Now all the glucose and amino acids and vitamins are starting to shoot down this tubule. Now, how is your body going to, is your body going to do? Is it just going to let all the nutrients and vitamins just go into your urine? No, it wants to reclaim the good stuff, right? And that's why you have transport proteins. Now, transport proteins, just talking about in general, like there are specific transport proteins, such as glucose transporters or amino acid transporters. But again, I'm just talking about them in general. And the thing is that you have a limited amount of transport proteins and a limited amount of nephrons and renal tubules. So therefore, you have a limited rate. If you have so many nutrients and vitamins shooting down this tubule that these transport proteins can't keep up, that means you've reached the transport maximum. Right, so this is the maximum rate at which a substance can be moved across the membrane. So why is this important? Well, renal glucose transport maximum, so renal referring to kidney, glucose transport maximum. So this is the maximum rate you can reabsorb glucose in your kidneys. So the thing is that, again, you have limited amount of protein transporters that can actually move glucose and reabsorb it from the proximal convoluted tubule. So what about hyperglycemia? What happens if you have two way above normal plasma glucose concentrations? Well, if it exceeds the rate and if it exceeds the concentrations that you can absorb, you end up with sugar in urine. So again, your renal tubules and your proximal convoluted tubule is trying to reabsorb as much glucose as possible. But if all that sugar comes down due to hyperglycemia, it'll be just like that sushi or chocolate example. It won't be able to keep up, and then you have sushi and chocolate moving all the way down the line. So this is why you get glycosuria with hyperglycemia. And if we're not talking about hyperglycemia, if you say they also have transporters for amino acids, so they're very creative. Amino aciduria, so abnormally high amino acid concentration in the urine. So again, what causes that? If you have too much of these nutrients ending up in your filtrate that exceeds the transport maximum, that's when you get the presence in urine, and then you might say, hey, maybe this person is having too much of these nutrients, or maybe something is wrong with their nephron and kidney tubules or renal tubules where something is damaging it so they can't reabsorb it. So that's another thing. All right, so we're done for today. Yay! So again, last urinary lecture, and